This is Christopher, your South Florida yacht expert. And today we are going to cover the 5 different types of propulsion systems used on modern recreational boats and yachts. And the type of propulsion system your boat or yacht has really can make a difference in your boating experience. So it's important to understand the pros, cons, and trade-offs of each type of marine propulsion system available in today's boat and yacht market. Now, all propulsion systems operate under the same basic concept. They have an internal combustion engine, gasoline or diesel, and they have a drive system that allows the power from that engine to spin the propeller of the boat. But they accomplish that in very different ways. And there are 5 types of drive systems we're going to cover today. Number 1, outboard engines. Number 2, stern drives, also known as inboard outboard engines or IOs. Number 3, straight shaft inboard engines. Number 4, pod systems. And number 5, surface drives. So we're going to start with outboard engines. So from the beginning, the outboard engine was designed exclusively to be used on boats. And because those types of propulsion systems were developed exclusively for marine use, they have evolved to be very functional in the marine environment. They can resist corrosion very effectively. They're typically a very compact package while still providing a lot of power. And they offer a lot of flexibility that no other type of marine propulsion system offers. Because of that, you're seeing outboard engines applied in larger and larger and larger boats today, up to and including 65 feet plus. Reliability is always a struggle in the marine environment, especially the saltwater marine environment. And among all the propulsion systems, I would argue that modern outboard engines are the most reliable power drive system you can use in a boat today. They're also the easiest to maintain. In addition, because you can tilt them up out of the water, either when you're at the dock or when you're pulling up into shallow water or at a sandbar, they allow less corrosion because they can stay out of the water when they're at the dock, and they make very easy shallow water operation because you can lift them partially or completely out of the water when going to a sandbar or in shallow waters where you're not sure if you're going to hit the bottom. The trade-off with outboard engine, of course, a lot of reason people don't like them, is you lose that clean aesthetic of a beautiful inboard powered boat. You have that big engine sitting on the back of your boat. And in addition, you lose that nice full swim platform that everyone enjoys on the back of a boat because you have those big outboard engines, anywhere from 1 to 5 outboard engines taking up what would be your nice swim platform space. However, they have become incredibly popular, and you're seeing manufacturers employ them on bigger and bigger boats because they have so many advantages. Number 1 is reliability and ease of maintenance in the saltwater environment. Nothing matches outboard power for reliability and ease of service. The top brands that make outboard engines for the American market are Mercury, Yamaha, Suzuki, and Honda. Let's talk a little bit about each of those brands, starting with Mercury. So Mercury engines are known for refinement and speed, and they deliver. Mercury engines, in my experience, are considerably quieter than any other brand of outboard engine on the market. And that makes a big difference when you're spending a lot of time on the water. They also offer a very smooth, silky operation with excellent power. Now, in the recent past, many of the Mercury outboards were supercharged, where you have an induction system forcing air into a small engine to give it the power of a big engine. But supercharging adds a lot of mechanical complexity, and we don't want mechanical complexity in a marine environment. And Mercury knows that, and they are moving to remove all superchargers across the entire Mercury lineup. Almost every single Mercury outboard engine is now what we call naturally aspirated. So that means there's no supercharger, there's no turbocharger. It is a traditional engine and it eliminates the complexity of supercharging. Mercury Outboards really is also known for innovation, in addition to their smooth, quiet, and powerful operation. Their new V12 model, the 600 horsepower Mercury Outboard, is the first outboard ever in history where instead of that big engine turning on the back of the boat, the engine stays stationary and only the lower unit where the propeller is turns. It's a really nice application. It allows for a much better, cleaner installation, excellent performance. It's really a fantastic innovation. It's also the most powerful outboard engine on the market today at 600 horsepower. Mercury is really leading the way in innovation, refinement, power, and performance. Now, that takes us to Yamaha. Yamaha is known for bulletproof, reliable engines, and they deliver that. Those engines are very, very reliable, easy to service, widely available, but the trade-off with Yamaha is they tend to be very noisy, especially their engines at the 350 and 425 and 450 horsepower levels. I've run boats with those engines, and honestly, they're too loud. They're just too loud. They're rough, they're loud, they're bulletproof, they're incredibly reliable. They make for a very unpleasant boating experience once you get above 300 horsepower in the Yamaha range. They have a new 4.3 liter V6 350 and a 5.6 liter V8 that is available at 450 horsepower. Both those engines, make sure you do a sea trial before you buy a boat with those engines. They won't break, they're incredibly reliable, but they are loud. Another outboard manufacturer in the United States is Suzuki. Suzuki is also known for excellent reliability, but they have some innovation as well. Suzuki is the only outboard manufacturer to offer counter-rotating propellers at the 225 to 300 horsepower range. Counter-rotating propellers means that instead of one propeller at the engine, there are two, and they spin in opposite directions. And that is a really nice benefit to any propeller-driven marine engine because counter-rotating propellers offset the torque that comes from a single engine that kind of is moving torque in one direction. They tend to increase efficiency. It's a really nice option for any engine, but especially an outboard engine in that 225 to 350 horsepower range. So the next type of marine propulsion system we're going to move to is stern drives, also known as inboard outboard or IOs. And stern drives were originally designed initially by a company called Volvo Penta, and they were designed because at the time outboard engines were limited to about 100 to 120 horsepower, so you couldn't get the power that a big V8 truck or car engine would provide. But people like the performance of that drive system where the propeller rotates, and of course people wanted and still want that clean look of not having a big outboard engine or multiple engines on the back of their boat. Stern drives, IOs, inboard outboards, today are produced by Mercruiser and Volvo Penta. And it is trying to do too much in my opinion. You're converting a truck or car engine. Volvo Penta offers gasoline and diesel. Mercruiser strictly offers gasoline engines. But you're mating a truck or car engine through a large hole in the back of your boat where that lower unit, as they call it, the stern drive unit, connects. And the mechanical complexity, that big hole in the back of your boat, and many other reasons, engineering, have resulted in what I would say is the least reliable marine propulsion system possible, especially in saltwater, but they're not that great in freshwater either. And stern drives are the one marine propulsion system I will never recommend. In fact, I will not even sell a stern drive powered boat because I know my client is going to be unhappy with that marine propulsion system. So stern drives, I hate to say it, they're just not an option in today's market, in my opinion. Then we move to straight shaft inboard engines. So a stern drive takes a vehicle or a car or truck engine and connects it to a complex drive unit that also steers and maneuvers the boat nicely. A straight shaft inboard engine is one of the oldest and timeless propulsion systems produced. It is a big V8 or much bigger engine in many cases, connected to a straight shaft of steel or iron that spins a propeller underneath the boat. However, there are limitations, of course, and those limitations are that that propeller does not move. So you have a rudder behind the propeller that turns like this, and of course that cannot provide the same level of maneuverability, steering, handling that a movable propeller like an outboard or even a stern drive can provide. But there's some advantages to very low mechanical complexity and the fact that there is no mechanical parts under the water. It's a piece of iron and a brass propeller or a stainless propeller, and it really is a very reliable solution, especially for larger boats and yachts. And that's why those are used, because at a certain point, big yachts are using engines with 1,000+ horsepower, and there is just no outboard engine that can deliver that kind of power. Sometimes they still struggle with corrosion, although at this point, the major manufacturers have really figured out how to protect those engine blocks from corrosion in the saltwater environment. Now, in an attempt to address the limitations of straight shaft inboards, the limited maneuverability, and the somewhat not great efficiency of that propulsion system, Volvo Penta came out with what's called a pod drive. A pod drive also uses a big truck or gasoline-powered engine. They really own the IPS pod market in yachts in the United States. And there's a couple advantages to this pod system. So a pod system comes directly down from the bottom of the boat. You're typically going to have at least two on a yacht. And what's different is every other propeller faces backwards. A IPS pod system, the propellers face forward. So that means they get clean water flow directly onto the propellers, and those propellers rotate, and they can rotate independently. So they're very efficient, typically 10 to 30% more fuel efficient than a straight shaft inboard engine. They also provide a nice smooth ride and smooth performance, and they're excellent for people who are running their own boats or any captain running a boat, because they offer excellent low-speed maneuverability. Volvo IPS pods are typically connected to a computerized joystick system, so that you just rotate that joystick, the computer controls those pods, forward, reversing, pivoting, and you have excellent, easy low-speed maneuverability. The offset with pods is, number one, you have significantly more mechanical complexity. So you have a big gearbox and drive system that extends underneath the boat into the salt water. And because it comes straight down from the boat, it also has a deeper draft. And it's a deeper draft, propellers facing forward, it is more vulnerable to damage. So if you hit the bottom with an outboard or a straight shaft inboard, unless you're going really fast, you're probably going to be okay. But if you hit the bottom or debris or something under the water with a pod system, you're going to have some serious damage. And those pod systems are actually designed to shear off and seal up so that the integrity of the hull of the boat will not be affected. And that pod just sinks to the bottom of the ocean. So it's expensive. It's pretty much going to be useless after that has happened, but your boat won't sink. It'll seal up and you'll be safe. I have known captains who have lost the pod and they didn't even feel it. Thing just popped right off, sealed up, and they kept driving. But a pod system, the trade-off, you get better efficiency, easy low-speed maneuverability, excellent high-speed maneuverability, because those propellers are turning, like, very sophisticated. They also have that counter-rotating propeller that we talked about. So Volvo IPS pods have two propellers offsetting the torque, and giving excellent grip on the water both at speed and low speed. Trade-off, greater complexity, more vulnerable to damage. Finally, we're going to get to a type of marine propulsion system you won't see very often: surface drives. Every other type of marine propulsion system we've talked about so far, outboards, stern drives, straight shaft inboards, and pod systems, the propeller is completely under the water. A surface drive has the propeller right at the surface of the water, and that propeller is spinning. A good portion of that rotation is actually out of the water in the air. So really only about a half to 2/3 of that propeller is in the water at any given time. And that offers a couple advantages. Number one, it is a very efficient way to produce torque and speed from an internal combustion engine. Number two, because they stick straight out the back of the boat and they're at the surface of the water, you have very little drag. And in addition, because the bottom of the hull is going to be well below the level of those surface drives, because they're up at the surface level, very little risk of hitting an object and damaging those drives. So they are used in specialized applications. They go very fast, and they throw a very dramatic rooster tail. Some people love it, some people may not like it, but they can push a very large boat at very high speeds. Of course, there's a trade-off, of course. Low speed, because that propeller is not all the way in the water, and it's a very high-speed design propeller, it does not grip well at low speeds. A lot of captains will not even run surface drive boats because low speed handling can really be a challenge if you're not used to using surface drives. Now, they kind of tilt down into the water in low speed mode for docking and so on, but they're not great for low speed maneuverability and handling. So like everything, there's a trade-off. They're fast, they're efficient, they're protected from damage, they throw a beautiful rooster tail or an ugly rooster tail, depending on your opinion, and they're a lot of fun. But low speed maneuverability with surface drives is really compromised. Finally, whichever marine propulsion system you have on your boat, you want to maintain it properly. One little tip I like is I like to use high performance synthetic lubricants. Now, of course, you can't go wrong with the manufacturer recommended, the manufacturer branded gear oils and motor oils in your product, of course. But I use a company, I have no affiliation with them. There's a company called Redline Oil that produces ultra high performance synthetic lubricants, motor oils, gear lubricants, everything you need for just about every marine engine on the market. You can give them a call and they'll help you select the products. But I'm a big fan. They work very well even with a little bit of water contamination, and they really, really protect both your gearing and the internals of your internal combustion engine. The other thing that applies also to any of these marine propulsion systems is you can often dramatically improve the performance of your boat, especially the way you like to use your boat, by optimizing the propellers. So here's a video about that. We'll put a link to that at the end of this video. But whether you run outboards, stern drives, inboards, pods, surface drives, modifying and optimizing the propeller for your specific application and the way you like to use your boat can make a really big difference in maneuverability, efficiency, speed, whatever you want to optimize. So my name is Christopher. I'm your South Florida Yacht Expert. Hope this has been helpful. Thank you.